So hello and welcome to Flying High with Flutter. I am your host, allenwyma. Today I'm with Thorsten Lorenz. Now, how I got to know Thorsten is that I got a notification about a very great project I think is really interesting. So in a previous episode, we went over how to connect Rust and Flutter together with Shady. And I think this is another big step forward in this process. So I'd like to go ahead and let him introduce himself and to talk about, what he's working on. So Thorsten, why don't you go ahead and kind of introduce yourself so people know who you are?
Yeah, hi, how are you doing? Thank you. I'm Thorsten Lorenz. As you mentioned, I have built a tool to make it really easy to basically write your Flutter apps like you usually would, but then write the app logic in Rust and integrate the two. I guess we can talk a little bit about my history, how I got here. I've not actually done Flutter professionally nor Rust professionally. I'm actually working for Cypress.io, where I'm working on testing tools to make testing in the browser and also eventually in Node.js much easier. I've previously worked on a bunch of other projects, a bunch of other languages. I've worked in C#, WPF. I've worked a lot with JavaScript, TypeScript, and the web. And I don't want to go too long. I want to give you a chance to ask also questions. But that's kind of like my background there.
Yeah, I mean, I would love to hear this because, to be honest, I thought maybe you would have some kind of background, at least in Rust, because Rust is not an easy language, right? So I think, so then your strongest language would be what? Would actually be Node.js, since I think you're working a lot with that?
I would say that, yes, I'm daily working with JavaScript and TypeScript. I'm pretty versed in C as well, C++. Because I'm a lot of times I'm working on the lower levels, also trying to improve performance and things like that. So I would say that I understand things to kind of from the top all the way down in order to do what I'm doing for my day job. With regards to Flutter, actually my very first app that I built with Flutter, I got interested. Okay, let me actually go there. Why I even wanted to do Flutter. I built a few years back, like I think 4 years back, I built my second poker app. I built another one before, and I built that in JavaScript for the web. And it was basically a better poker.net was the name, and it was very interactive. And I built it to where you could use it on mobile, and you could use it on in the browser, and you could use it on desktop and everything. And I made it work. And it's basically a progressive web app, and with that it works offline and all these things, and it works on all devices and so on. However, to make that happen was really tricky, and I definitely learned about the limits. And I've kind of came to the realization that the web is kind of not made for certain apps, especially if they have high interactivity. The web was made for documents originally, and then tried to kind of change things to make it work for apps. And Flutter, on the other hand, was created with mobile apps first in mind. And instead of trying to use a technology that's not made for what you're trying to do, I said, okay, let's try Flutter, which is actually made for what I'm trying to do. So at that point, just to get my feet wet, I built my first app, and I had this idea to build a YouTube downloader, so where you basically can give me a link of a playlist of a video, and you can download it to watch it later. And I submitted that to the Play Store, and I'm probably one of the few developers where the very first app that they submitted was rejected, because obviously Google doesn't like an app that allows you to do that. So what I learned also from there is that I probably should have built a minimum prototype first and just tried to submit that, because I had like everything perfect in that app. I had like proper state management. I had the downloader plugin was working perfectly. I think even in the background it kept downloading. All these things had all worked out. And then I couldn't even really submit it. So that was my lesson learned there. But that's how I got into Flutter originally. And after that, I wanted to see what else I can do with it. And I had the idea to build a game. I always wanted to build. I built games when I was a kid, but not really serious ones. So I wanted to still build the game and also see how far I can take Flutter. And I actually learned that for 2D games, it's actually works very well. The camera support is great. The performance is great. It works on my game that I created, Bat UFO. We probably include a link in the show notes. It works on the browser, works on Android, iPhone, on the Mac, everywhere. So that was a really good experience. And now we get to where I started using Rust, is because I wanted to see if I can maybe, like how much more can I push performance, and maybe also for a 3D game. And that's how I got to learn about Rust. And I actually had refused to look at Rust for the longest time because I didn't want to do what everyone else was doing, mainly. And then I looked at it and just fell in love. I have done Haskell before, and it seemed like Rust took everything from Haskell that I loved about it, but made it somewhat more accessible and actually more practical to actually build real applications with it. Not saying that you can't in Haskell, but from my experience, it was a little more tricky. Also, the whole idea is about not needing a garbage collector, but still having memory safety and performance and all these things just like really drew me in. The highly functional interface. It's like basically it's a rich language, but still performant. I could go on and on. I really fell in love with the language. And actually, when I started learning Rust, I immediately thought about how can I maybe connect these two things like Flutter and Rust, because I also realized that Rust didn't have, and probably still doesn't, a really good UI framework. And also multi-device support is still tricky. So Flutter has that. And I'm going to stop here so give you more chance to ask questions. But that's how I got into these both these technologies.
Yeah, it's okay. Talk as much as you like, because I'm really interested in your ideas, because of course we all have different ideas, right? Different perspectives. But I think a lot of what you're saying definitely resonates with me. You did mention that you said you didn't want to do what other people were doing with Rust. Like, is that like this idea of rewrite everything in Rust? Because that seems to be kind of the joke, is that, oh, we have Rust now, so let's rewrite. Like now there's a pseudo rewrite. I think it's called Please or something like that. Like there's a lot of rewrites going on.
I don't think I had. Is
this what you mean by?
I don't think I had a rational reason. It was just like, oh, everyone is jumping here now. Like it's the fad of the day. And I think I was also just interested in other things at that time. I just and then when I did actually look into it, I was just like, wow, why didn't I look earlier?
Yeah, definitely. So let's see, site person, everything. Okay, so you actually just kind of. This is really more of a passion project that you started, right? You like Rust, you like Flutter, and you just wanted to combine the two. Is that where the idea came from, or did somebody come up to you and spark an idea, or what happened?
So I think you could say that. So basically, when I did use Rust, I played around with the Bevy engine as well, which is a gaming engine that I think an ex-Microsoft person, I can't remember his name right now. I think Cart did that, and it took off, and I played with that for a while. But you can't really build an app with it. It's made for building games. And then I wanted to build apps, and I looked into things. I looked at IMGUI, and it's just not that mature. And I also wanted it to work at all devices. So obviously the next thing was to consider like doing it as a web app, and there are. And Rust, as you probably know, has Wasm support. So you can basically compile to Wasm. So you can basically kind of create some Rust app that then compiles to Wasm, that then basically runs in the browser like a web app. And I did that. There are numerous libraries out there. The one that I used was Seed, and it worked. I got my little workout app that I wanted to build, and it's still online and everything. I use it actually for myself. But then basically once I started looking at how to build the UI, like I was back to where I was when I ran away from the web, where now I had to use CSS to basically to style things. I didn't have the all batteries included that Flutter has, where you just have all the kind of widgets that you need. They're already there. You don't have to, and I'm not really good at UI design at all. So I like actually have everything ready. And the other thing is I'm also colorblind. So if I have a ready-made theme, I at least know that everything makes sense for people that are seeing colors better than I am, and so on. So I was like, why am I doing this? Like now I got Rust, but now I'm back building apps like almost like the web, and that wasn't the idea. But at the same time, I didn't just want to. I really liked Rust. I wanted to combine it, right? I didn't want to just do Flutter, and it's not that I don't like Dart. Dart is actually pretty, really useful and really productive language. Especially, the whole idea of being able to inject code into the VM and thus enabling hot reload and so on. I still felt, though, that it was kind of a C#, but a little less versatile. I never felt like 100% comfortable, but I'm not. When I built this game, I was fine. It's probably more like I really wanted to work in Rust. Let's just put it that way. And the other thing is, it's not only that reason; it's also that you get a bunch of security and you get a bunch of performance benefits when you work in Rust, right? Like basically, when your app compiles, you didn't do anything wrong, almost, right? You can easily write tests and test the app logic that way. With Flutter, it's garbage collected, but you could still have memory leaks. They could never. So Dart could never be as fast as Rust. It has other advantages, but it's just the nature of the VM and everything. But I know that Dart is pretty damn fast though. But Rust you can still get a little more. Threading is probably more natural in Rust. As far as I know, in Dart the only way to put something on a different thread is to use isolates, which as far as I know are more are heavier than just threads in Rust. Things like that, and then I looked into solutions. I looked at blog posts and little sample apps that you could do, and it was pretty complex to get it integrated. For Dart, it's actually fairly easy because all you have to do is you compile a binary with Rust, and you stuff it somewhere, and then you tell Dart to load it. With Flutter, it's a little more complex, mainly because for iPhones and OS X and so on, the only way there to do it is you have to wrap it all in a plugin. For Android, actually, you can also just put the file somewhere and have it loaded. So I looked into all this and I was like, this is actually what I want, but I don't want it to be that complex. And I don't want to write all the boilerplate, and I don't want to have to worry all the time that I don't make mistakes. So I was like, wow, this is actually an opportunity. What if I could just annotate my Rust code, and then it generates all that for me? And then I have a tool that basically puts things in the right places, and you just like run a few. Obviously, at this point, it's still scripts, but you just run like some binary tool that helps you with this, and you're off and running, right? And the idea there is that how I envision it is that you write your application logic in Rust. All the state lives in Rust. You test, it a lot, right? And while you're probably iterating your writing tests, you're iterating your Rust code by writing tests, and then you build the UI, or maybe you do it the other way around. But the idea is that while you're building the UI, you have the hot reload or Flutter, right? So now your application logic works, and you can just try things out, and you can move things around, and you can do whatever you want, and you have this quick feedback, which you don't have with Rust, right? Because Rust still has to compile. I know that there are projects for Rust, especially for game engines, that are trying to like implement or like invent some dynamic language, or some whatever language, like a scripting language, so you don't have to recompile every time you change something in your game, right? But I'm thinking, okay, well, Flutter is already well established. It works everywhere. Why not do that instead, right? So that was the whole idea behind that.
Yeah, that makes a lot of sense. I think also with your business logic, it's usually more straightforward, right? Do this, do that. But yeah, with UI, it's always, okay, oh, this is one pixel off, or this is not quite right. Let me copy and paste that, and let me change this around. So I think that also makes sense too.
Right. I mean, also like if you're writing, if you're like test-driven, and you just write a test and you just run it all the time, and you implement your code in Rust that way, it's actually not that long of a feedback loop either, right? I mean, the compile times have gotten a lot better. But yes, once you are moving things around, you don't want to have to restart every time or whatever. So then you're just in Flutter. The caveat to note there is that even if you would recompile your Rust code, and let's just say you have your app running and you change your Rust on the other end, you cannot just hot reload and see those changes, right? Basically, you have to restart the app because it has to reload that Rust library in. So that's a thing to consider. That's why I'm envisioning it kind of like that workflow.
Okay. That makes a lot of sense. So you actually found a way to write your Rust code and it will compile to Wasm, and Wasm can be loaded from Flutter Web. Is that also true, or you haven't gotten that far yet?
That's something that I have not implemented yet, but I don't see why it can't be done. Basically, RID right now is, I would say, in its early phase, where I definitely would not ever say it's production ready yet. I would call it early alpha. But I kind of proved out for myself that what I'm trying to do would work, right? And that the workflow is kind of smooth enough, and yeah, that pretty much everything that I need to be able to do, I can do. And then Wasm support is something that is somewhat on the horizon after I figure out some other things. But basically, the only difference there is instead of compiling to a binary, that's like a library that gets loaded, you compile to Wasm, and then you just have to make sure that the interface to Wasm, there might be some JavaScript bridge that I'd have to generate, right? So I mean, we can talk a little bit about how RID works in order to make that a little clearer. Unless you want to go and show some code or the app, it's up to you how you want it.
Yeah, you know what? I don't even know if we really properly introduce exactly what we're talking about. So why don't we start from the top, right? So RID is the name of the library. I believe it's called Rust. I forget what the I is.
Rust
is
integrated
infused,
Dart.
or what is it again?
Rust integrated.
And that's right,
I just
integrated
needed
Dart.
like a three-letter acronym so you could use it for namespacing your macros, and I had to invent something.
Okay. So Rust integrated Dart. It's actually like almost, I would say, like a whole ecosystem, right? You have to use this generator to generate everything for you. But what it basically gives you, I think at a high level, the main thing that it does is it will create a plugin that's directly within the app itself.
Right.
Right. It's in a subdirectory. Yeah. And probably also some niceties too, where, you do the thing which caught me once. I did do Rust with Flutter once. And the thing that took me quite some time to solve, which was the tree shaking of Mac OS, or iOS should be the same. So if you don't call C code from within the Swift code, it will just be gone, right? It'll be it's called tree shaking, where the app tries to figure out what you actually don't use and just shreds it. Right. That took me a long time to figure out. I'm glad that you found that. Right? Did you also get bit by that too, where you couldn't figure it out?
No, I mean I knew that because I had done some tutorial. Someone had published where they basically inserted that code into the Swift class and put a comment there where it said you have to do this to prevent tree shaking. But I guess to explain this, let's start from how would you do it without RID, right? How does it work? So basically, what you would do is you write some Rust code, right? And then now you want to integrate it with your Dart or Flutter app, right? So now what you have to do, you have to write functions that can be called from Dart or Flutter. And the way you do this is you write an extern C function, and you tell it to no mangle, which is an attribute which basically tells Rust, don't change the name of this function because I'm going to call it from somewhere else. So I need to have that name not change. And then what you do is you run cbindgen, which is a library for Rust, which basically looks at all your code, and it looks for these external C functions which have a no mangle on it, and it basically pulls those out into a C header file. And it does the same thing for structs. If you put a repr C on the struct, it will actually pull out the fields as well and try to represent them in C. If you don't, it will treat them as opaque structs. And we'll probably get into that in a little more detail later. And then basically, so that gives you the header file. And then you run a tool called ffIgen, which the Dart or Flutter team have provided. And basically that looks at that header file, the C header file, and then generates Dart code that can then call functions that are basically spelled out in that C header file, right? And so those so it basically generates some Dart that you can then call, and it loads the dynamic library in, and then basically tries to find, whenever you call a function, it tries to look up that function in the binary that you generated via Rust, right? It doesn't even care that it was Rust originally. It could have been C or anything, right? So that's how that works. Now the API is not super easy to use, and again, you still have to write all this by hand, right? And then also what it does is if you had a struct that then got pulled into the C file as a struct, into the C header file, it will actually generate a class with fields and all these things on it. And so that's basically what that provides you. And then basically what RID does is it does multiple things. First of all, it with a single attribute on your struct, actually we probably should share screen. I know that in the podcast people will not hear or see what I'm sharing, but I probably will. I'll talk along to where it's not necessary to actually see it. But basically, if I look here at, let's say, the source file here, which is over here already, we basically annotate RID model, and then it knows to basically generate accessor methods for all these fields. Basically what you have to tell RID also is like, for instance, here I have a to-do type. It needs to know that it's a struct, so I can basically tell RID this is a struct. And the filter type, for instance, we have a filter type here on that model, is a filter. It's an enum, so we have to tell it that. And we can also tell it this derives debug, and then we tell RID that please also access. I want to access this debug method from Dart, so I don't have to implement toString as well, right? And that's pretty much all there is to it. Now, what happens under the hood is actually RID will generate an opaque. It will treat this as an opaque struct, meaning I don't want Dart to actually generate, or the FFIGen to generate classes for it, because let's just say you wanted to get this model, right? And now I have to instantiate it in order to even just get it. And then if I have to-dos, now that means I have to fetch all the to-dos. And that can get expensive because you're crossing the FFI, like the foreign function interface barrier. So what I did instead, I said, well, I'm just going to give you a model, like a pointer, and every time you ask for something, like let's say you ask for the first to-do, that's actually when I go and I'll just fetch that. So I made it more performant that way, right? And so that's, and I guess now I can stop sharing because that's what I wanted to show there. Now that is basically what RID does for the Rust side, right? It generates all the Rust code. It generates, actually, I'm going to share again because it becomes clearer when I just run expand on it. So what you actually can do, you can run in, let me just do it here. In your, well, I don't want to do that. Let's see. What you actually can do, you can run cargo expand, and hopefully this will work here, and then it will basically expand all the macros and everything that gets kind of generated. And right now we're building, and the reason why it's building is because right before this I wanted to run this on iPhone, so I built for iPhone, and unfortunately I haven't figured out how to once you compile it for one architecture, how to make it, not forget everything that it did for the other architecture. Obviously, right now it's also compiling everything that's RID, which in the future won't be the case when it's a proper crate. And I hope we want to get there. But basically, what it does, it generates all these external access functions, and probably. And yeah, now you can see all the stuff that it generates, right? So what we're seeing here, for instance, for the people listening, we see a function here that has a no mangle, and then it has a pop extern C, and then it says RID message start all, and it takes a model pointer, and then it does all this gnarly code to resolve the model from that pointer, and then it basically calls the, in the end, it ends up calling the model update function that the user implemented. So all that gnarly code, you don't have to write because RID does that for you, right? So that's that part. And now what it also does is it generates the Dart access methods to it, right? So FFIGen already creates methods that can call these Rust functions, but it's not a nice API. So what I did is via extension methods, I made some nicer API to, for instance, where you can say model.message add to do instead of having to call some weird named function, and then basically it knows how to basically call that underlying, like, let's say, lower level dot function to make that happen. And so that's pretty much, I think, all that the quick rundown of what it gives you. Like, gives you really fast integration, gives you a really nice API, and to get you going quickly with basically both languages.
So how does because I'm pretty familiar with Rust. I'm much better with Flutter, obviously, but so all the state is actually still being managed by Rust, right? So you have like some kind of piece of memory that's always available.
Right.
I'm kind of confused about how this works, because I know that once it goes out of scope, that means that Rust will try to clean it up, right?
Right. So basically, that's the most challenging part of the whole project, getting this memory management right. So basically, the current version that I have of it, just to get it started and to see how it could work, assumes everything happens synchronously. So, for instance, in the case of to-do, we say add to-do. So you call that from Dart or from Flutter. You say message add to-do, it gets added, and you put that inside a set state, for instance, and then that will cause, after that Rust function was called, it will cause the widgets to be rebuilt. Now, what in the build thing, you then go and say, model, give me the latest to-dos, right? You don't ever, the idea is you don't hold on to state in Flutter, right? So you basically say model.todos, and basically the API that I implemented there, and I forgot to mention that, is an iterator API. Even though it's like a vector that you're getting that's actually a pointer under the hood and all these things, like you can actually say for to-do in to-dos, you can iterate as if it's all Dart, like you used to, right? You can convert it to a list, you can map over it, all these things. The idea is, though, that you never hold on to any state across builds, right? You get it fresh whenever your widget is getting built, but every state you basically need, you get it directly from the model. And that's the easy part, right? Because if the model holds on to the state, Rust still has it, right? We don't have to worry about it being cleaned up or anything, right? So basically, I can just give you a pointer to the model, and then I can resolve everything once you ask for it, right? Or I give you a pointer to the to-do vector, which also is held on by the main model, right? And then you can still iterate over it, but we don't have to worry about cleaning anything up because Rust actually still holds onto it. It's part of the singleton model, you could think of it, right? Now, it gets more complicated if you want to create new data and not put it on the model, right? So for instance, we have in the to-do app, we have a filter method. So you can say filter all the to-dos, by if they are complete or not. Well, I can return a reference to the to-dos, right? So I don't have to copy the to-do structs, but the vector that holds those filter to-dos, well, that's created, and now that's sent to Dart. Well, Rust would clean that up, like you said. So I have to basically, there are some techniques in Rust where I can say, box it into something, and then make Rust forget about it. You can say, forget about it, don't clean it up. So now Dart is the only one that knows about this thing. It basically has a pointer. Rust totally forgot about it, right? And then obviously, every widget build, when I now get the new vector of filter to-dos, if I don't clean that vector up, I would leak vectors. Wouldn't be huge, right? Because it's just a vector. It's not actually the to-dos. It's just the slots, right? But it still would be a memory leak. So in that case, there has to be a mechanism where every time you get a new the new vector, you have to make sure to clean up the old one. And the only way to do this is to tell Rust, hey, I'm done with it, because Rust has no notion of what you're doing on the Dart side, right? And so that's somewhat of a challenge. And you mentioned, Ellen, that you didn't like that you had to worry about this as user manually, right? And I totally understand, right? I totally get that, and I want to basically see how I can make it more intuitive, or maybe how I can. Unfortunately, Rust doesn't have like an auto dispose kind of thing, like an auto cleanup. Like if something gets garbage collected, for instance, maybe it could clean up something else with it, right? You can't actually make Dart do that. But I'm going to have to think about some other mechanism to make that easier. But basically, the matter of the fact is like once you send something to Dart, and every time you re-enter Rust from Dart, right, you kind of for a moment lose the guarantees that Rust gives you, right? For instance, if I give you a mutable pointer to the model, which I then can resolve to the mutable model, well, now I could have two mutable models going on, which in Rust is normally not possible, right? Rust protects you from that. So what I'm basically working on right now is I'm working on how can I make asynchronous code work properly. And I basically have a branch on Grid right now that where I'm using mutexes and read-write locks, or either, whichever will work out better, to kind of reestablish those guarantees. So every time you basically enter, from Dart, I basically take and you want to read the model, I take a read lock on it. And if you want to write to it, I take a write lock on it. And that way I get back those guarantees without the user having to worry about it. But as I mentioned, this is, in my opinion, the most tricky part. And that probably is not only in my project. It's probably in any project where one language gives you guarantees, but you're basically doing some really low-level stuff to integrate two different languages together, right?
Yeah, I also saw that there is an isolate library. Are you planning on using that within Rust? Because I know I've seen it and I think I've used it, the isolate library for Rust.
Right. I'm using it in that branch. It's called the Allo or IO isolate, ALLO. And it's basically just an implementation of the Dart isolate in Rust. And what I'm using that for is not to create threads or anything, but I'm using that in order to post messages back. So let's say I say, okay, get me this web page, right? Or like count the lines in this web page. I don't know, whichever, right? Well, the thing is that cannot happen synchronously, right? Because it has to be a web request, and you definitely don't want to block your main thread while the web request is being handled, right? So now I have to have a way to tell you when that data is there, right? When it's done. So basically how this works right now in the branch that I have, you fetch, you do everything. You can even go in a different thread or whatever, and then you just post back with the same request, like basically when Dart, and that all happens under the hood. When you basically send a message, it has a request ID, and then when you resolve the, say the web page, you include the request ID with the post back, and you can say also kind of like what happened, like there's an enum of kind of topics of responses. And then you post that back and you say, okay, I'm done with this. And now what you would normally do then is, depending on what state management you're using, you would say, now I can rebuild my widgets, at which point it will go to the now updated model and will fetch all the updated data and render in a different manner, right? So that's what I use the isolate for.
Now that you talked about enum a little bit, I am kind of curious because there's of course there's enums within Dart and there's enums within Rust. Like, is there any kind of easy way to kind of send those across, or you probably have to do some kind of translation to do this between? Do you know?
Yeah, enums. So obviously in Dart, the enums don't have a payload. That's actually a proper Rust term for this. But basically the enum variants in Rust can have data associated with it, right? You can put anything into an enum. So those are actually used for messages, right? So basically when you send a message from Dart, you find the message with basically an enum that has different names or variant names, and whatever you want to send along with the message is basically the data. Now, basically, those when Dart sends that, obviously Dart doesn't have such enum. So what I'm actually sending is I'm sending integers to index, which have the index of the enum, and then I send the data separately. And then on the other end, I piece back together that enum, the Rust enum, and call your code as if like Dart called it with a proper Rust enum. Then with the postback message, it actually has two parts, right? It has the topic, like for instance, you made a request, so you can say request completed. That's your topic, and then you have the request ID. And what I actually do there is I stuff that all into an int because I don't need that many request IDs, nor will I ever have that many variants. And it's actually cheaper to just send one number back instead of sending like a struct. So I'm basically do some bit shifting back and forth to pack it and then to unpack it on the Dart side. And that's kind of how I can stuff more information into one end. And that also works for enums in general, right? You can basically represent enums as integers, which basically then are the index of the variant of the enum, right? So as long as the enum doesn't have data, that's actually pretty trivial. Oh, and maybe I should then talk also about strings. So strings are also a little bit tricky, right? Because they like ints and all these things, like you don't have to even clean up, right? Because they're primitives. But once you send a string from Rust, you actually have to make sure to clean that up. But that already I handle really well under the hood because I instantiate the string as a Dart string, which you have to do anyways, because you're getting some UTF-8 kind of byte array from Rust. Then I basically convert that into a Dart string, and immediately after that I call free on that string, basically telling Rust I'm done with the string, you can now collect that. Because again, that string leaves Rust, and now it's basically, right? Rust doesn't care anymore, so I have to tell it, hey, I want to clean that up. And basically, free, all that, or how that works is you just give it the pointer, you resolve the pointer to the actual string in this case, and you just let it drop, like so you leave the function, and then the string automatically gets cleaned up.
Okay, sounds like you really spent quite a bit of time on this. You know a lot of stuff about this.
Yes. There's the Rustnomicon or something like that. There's a really good book about this. We should probably link it. I didn't put the links in, but that I read.
The Rustnomicon, right?
Yeah, and a lot of experiments. So one thing I want to say that when I started, I did Flutter, a Flutter app, and then I realized this is way too complicated, and I realized I can just do this in Dart. And then basically now I could basically just do something, play with it, and just run it quickly and have see if it works. And what I also did is, since it becomes like an executable, you can just run it with Valgrind, right? I'm not sure if you're familiar with that, but basically I ran that and I made sure that I'm not leaking. So I had I wrote some test script that did certain things. And then I made sure that I'm not leaking any memory. And obviously, if you do the opposite, like you're trying to free something that you didn't allocate, you kind of crash immediately. So that I know that I'm not doing that. So I wanted to really make sure that I'm not, like with the vector, for instance, right? When you clean up the vector, you have to really make sure to clean everything up. The tricky part there is that the Rust vector is a fat pointer, which includes not only the start of the vector and the length, but also the capacity. And you have to properly send that over back and forth to reinstantiate the vector correctly. So yeah, I did a lot of investigation experiments, and I think I started probably in, I think early February on this project. So it has been a few months, lots of nights and weekends went into it already, which why we'll talk about later the whole sponsorware idea came from.
Yeah, I mean, so I'm so curious though. So Valgrind, like you use this because you actually have to use some unsafe Rust, because obviously we know that Rust is able to manage memory for you.
Right.
But just, you need to use this because you have to use some unsafe, right? Okay.
Right. Fortunately, so Rust,
yeah.
Rust, if you don't use any unsafe features, you're by definition safe. But fortunately, Rust gives you, for these special cases like this kind of library, the opportunity to say, oh, this is unsafe, I know what I'm doing. Usually you put a safe in there and kind of say, like, this is safe because X. And you have to really think hard about what you're doing when you write unsafe code.
Okay, so Valgrind, I know Valgrind is obviously for like C, C++, so it's actually, you can use it across whatever as long as you can compile to binary, right?
Yeah,
so you can even use it on Flutter apps with Dart, right?
I have not used it on Flutter apps, but I have used it on Dart, because Dart you can actually tell it to compile. So it will compile it, and now you can run. And obviously I wrote a script that automates all that compiles it and runs Valgrind on it. Grabs out the important sections, and I could immediately see if I had a memory leak or not. And that's basically how I hardened these libraries, specifically the vector implementation. Made sure that I'm not leaking anything, nor am I crashing because I'm accessing freed memory or something like that. Because that's like the worst, right? I mean, that would kill anyone using RAID immediately if you're you write your Flutter app with this and you deploy it, and the app just crashes. And it would crash pretty mysteriously because it's crashing somewhere in Rust. But where's the mistake now, right? Is it in Dart or whatever? So I really made sure that this is solid, right? And I'm going to keep making sure that the whole memory story is solid.
Yeah, that's good. Sorry, I do want to go back to one more thing because I know that with Rust and Dart FFI, right, they can actually connect directly. So I'm curious if you've ever tried to run the app on web. I mean, I guess it would just fail immediately, Like, and also, do you know if they're going to try to have like a Wasm support? Because it seems like every platform but web has Dart FFI, right? So it just seems to me that Dart FFI at minimum should at least connect to JavaScript. Do you know anything about what's going on with the web space with this kind of thing?
So basically, what I have in the generated code is it looks at the platform, right? If you're on Linux, Mac, iOS, whichever, and it loads the library differently, right? I can actually let me just look at that code because that's generated here. Let's see. Maybe I share. Are people? Is it important to share my screen or is it not at all?
Yeah, I mean, you can feel free to share it so whoever works.
Right. So here, for instance, it says, open the library, and then if it's Linux, I call dynamic library.open, and it's an SO file. But on macOS, on iOS, it says dynamic library.executable. So it's different how these libraries get loaded, and even like the type of the library, if it's a dynamic or a static library, is different for the platform. Now, for Wasm, you'd have to do something different. So right now, I don't have anything in place for that. But as I said, if you just would compile Rust to Wasm, and then you put basically a JavaScript shim on top of it that knows how to call into Wasm, right? And then basically you call that from Dart, right? Something like that, something along those lines I'm thinking. But I haven't investigated that a lot yet. But at the same time, I'm committed to make RID work on every platform that Flutter supports, right? I mean, otherwise, it doesn't have as much of a point in the end. But right now, I have like a lot of other things I want to look into. So it's kind of on the. I actually have a roadmap on my website, and I think it's the third item on the roadmap or something like that. People actually ask.
Well, I did take a look to see. Yeah, I'm seeing, and I just did a quick check while you were talking, and I did see that people are asking, "Oh, hey, I can't use FFI." They said there is a package, JS package you can import. So I would suppose that you can probably somehow generate whatever you need and just depend on this JS package for web.
Well, I mean, the other thing is, if I had we were going to talk about that later. If I had enough sponsorship and could dedicate way more time to this, I could just implement whatever I need. The thing is that. I am fortunately, since I have worked with all these technologies, I'm in a really good place to try to make this work, whichever it takes, right? Whichever needs to be implemented, I'm pretty confident that I could make it happen if it's not there yet, right? Or help with every project. There might be a project that, like you mentioned, that may not be complete yet or whatever, and I could help there. So definitely, eventually, I want to make it work like that.
Does your employer know that you're working on this, or this is
no? This is all.
They're not saying anything.
This is all nights and weekends, which is. I mean, you have to have a lot of passion for something to dedicate that much time for it. Usually, what I have been doing this for years now. That whenever I have a job that is in some technology, I usually find another technology to spend my free time in hobby projects, and then a lot of times actually that then would become my next job. So that's how it works sometimes.
Well, the reason I asked is because we had another guy on here who was like you. He was very deeply into Flutter or at least he was deep into Flutter on his side, deep in another tech. And he was doing something else for work, and then he got GDE, and then the boss kind of said, okay, maybe this has got something to it, and then they started to introduce it into the company.
Interesting.
So I was curious if there's anything like that, where they see, oh, this guy's really into these things, let's take a look at it, maybe it's actually worth it.
Right. I mean, I have some ideas. I mean, ideally, Google would help me out a little bit, right? Because in a way, I'm helping their technology become more popular, more usable in a wider range of scenarios. But we'll see. I'm gonna have to write a few emails and see what happens. But right now and maybe we could just segue real quick into the sponsorware idea that I have. Basically, what
I was just going to mention that we should talk about that, and I also kind of find it funny that you talk over here that you grew up in a communist, with communism around you, right?
Okay, so let's start with the communists then, and segue into the sponsorware. So, I grew up. Yes, I grew up in East Germany, where and I was still a kid almost once the wall came down, but I still basically, I don't regret it because I got to view two kind of systems of society that are totally opposed to each other, capitalism and, well, not totally opposed, I wouldn't say that either, but capitalism and socialism. And I can see the value, or like you could say communism, but I mean, they're kind of really, the lines kind of blur. But basically, I got to see that some values that we have in capitalism are maybe not the best, which is it's all about money and kind of like greediness and things like that. And where when I back then in socialism or whatever, since the money wasn't worth that much, you couldn't just buy everything. For instance, you have to wait for a car. You'd have to wait like 12 years or something to even buy it. Even if you had the money, it was just not available unless you were with a party, whatever, right? But basically, the values kind of were different. People were not that crazy about money. They helped each other more, I would say, and so I got to see that, and I kind of see that where. Nowadays, where people are trying to do open source and all these things, and where they're really dedicating time to it, and they're doing it out of passion and trying to help other people, and then they basically have to fight to even survive, right? And invest also a lot of emotional emotions into it, and have to deal with people that are demanding they fix something when I mean they're just doing this on their weekends, right? And they kind of complain like, why doesn't this work? Why isn't this fixed yet? Well, yeah, because no one's paying me for this. So I listened basically to a podcast. I can't remember which one it was, but where some guy that did a PHP project that became really popular. He basically just published a tweet saying, look, I got this working, and I'm going to publish this. If I get X amount of sponsors, I'm going to make it public. And for him, it worked much better than for me. He just basically, I think, overnight got the amount of sponsors it needed, or in really a few days. And in my opinion, that's like the only way to make open source software, like projects like this, sustainable, right? Let's just say, like, I publish a RID now, and I make it available to everyone. And let's just say it was further along, people start using it, right? And they start depending on it. But now maybe I have no time now, like, because maybe I have other things, for work that demand my time, or maybe I just choose to not, work on the project anymore because maybe I have other important things in life, and basically I since I don't get any money for it, I can't say, okay, well, let me do this as my day job or something, right? And let me enjoy the day after, like, the nights or whatever. So that would, in my opinion, that's almost a little bit irresponsible, right? Because I would be releasing a library, people would start kind of depending on it, and they would start investing their time in it, and I can't even guarantee really that I can maintain it or that I can keep evolving it because I have no monetary support, right? So in my opinion, it's actually more honest to say, well, you know what? I'm going to need at least X amount of financial support in order to make this feasible, where maybe I can either work less or I can justify at least spending all this time. Or maybe, if it's even enough, I could even say, okay, I'll make this my day job now, right? And that's kind of like the sponsorware approach. Like, and I would almost call it like sponsorware to make open source projects sustainable. That's the whole idea, to make it sustainable and to have some responsibility about them, right? And the other thing that I'm thinking is that if I, like, basically in my case, I'm saying that if I get to 60 sponsors, I will open source it, right? I will open source Red and make it available to everyone. Everyone can use it. And I feel then confident that I can keep evolving it. I can keep addressing issues. I can maintain it, all these things, right? Everyone who sponsors me, like I say today, gets immediate access, right, to Red. They can start using it, playing with it immediately. But basically, once I reach 60, I feel confident. Okay, this is enough now. I can publish it. The other kind of benefit for this is to say early on if a project is even interesting to the community, right? Because people might go on Reddit, they like it, they like the video, they think this is awesome, but only once people are actually willing to also invest, in this case, money into an idea and help me out financially, that's when they really show that this is really something that we want. Please keep doing this. I'm going to give you, I mean, it's not even that much, right? The minimum you can sponsor me with is $10 per month, right? I mean, some people spend that in 2 days on coffee or something, right? So I feel like this is actually, not too much to ask. And my logic also is, if I don't get to 60 sponsors, well, maybe then I should start doing something else, because it seems like the community is not really that invested in it, right? But obviously right now I'm working on it still day and night. And the idea is to, every time I reach some milestone and I can implement another example app with it, I'm going to make a video, I'm going to, put it on Reddit and hopefully get more sponsors that way. Right now I have 11 out of 60. So I'm slowly getting there, but I'm still somewhat far away. Which also brings me to a little bit how I'm developing, right? So basically what I'm doing is I'm just taking an example app, right? In this case, in the first case, I did a to-do app. And then I basically just implemented, first I write all the raw code by hand, right? I write what would I have to implement to make this work? And then piece by piece, I basically regenerate all the boilerplate. And that's basically what I'm doing now for the async app. The simplest example I could think of was to write a clock that you can just start and stop, or like a stopwatch or something. And because there has to be a thread that is ticking, right? So now there's asynchronicity there that updates the model. And so that's kind of how I'm driving these features, right? And the next bigger project or the example app that I want to probably show is I want to use the block pattern for the to-do app to show that this is actually possible and how it could work, and then probably like a Reddit ticker or something like that also requires asynchronous requests and to show how this could work together.
Okay, sounds like you have big plans for this, and I totally understand what you're talking about. I think I know which podcast you listen to, because I do remember hearing this. I think it's for Livewire, and yes. The same guy who did Alpine.js. Yeah, I think it was Changelog. I can't remember which podcast it was, but yeah, I definitely know what you're talking about.
Several, yeah. Mm-hmm.
So I'm quite familiar with this because I work a lot with Elixir, and LiveView is definitely something that Livewire and LiveView are very similar, and actually a little bit work together too.
Nice.
Anyways, that's. I mean, I think we can keep going on and on and on, right? Because you and I are pretty passionate about mixing Flutter and Rust together.
Right.
I think it might be better if we schedule another episode to go deeper, right. And maybe also kind of see where you're going and if your sponsorship is ticking up. I want to start to kind of wind down this podcast so we don't go too long. But is there anything else you wanted to mention before we move on to our closing questions?
Well, I mean, one thing I wanted to mention is we haven't talked about my lifestyle, which is a very nomadic lifestyle. I basically live, technically I live in Cheyenne, Wyoming, but practically I'm more than not in South America. And actually I was recently in Cali, Colombia. And I want to kind of give a shout out here because I basically, just a few weeks after I left, some protests basically started happening in Colombia because the government, which already is very favorable to the rich, wanted to take even more from the poor. and so protests broke out. And I feel like the world is not aware. So I know this is not a political podcast, but I kind of want to just to give a shout out that the world is not aware of what's happening there. People are basically getting killed by the police or by paramilitary people, like civilians that are supported by the police. The government brought in the military. So I want to give out the shout to all the people there. All my friends are in Colombia. The people in the primera línea, stay strong, resistencia, do good job. I just wanted to take that. And the world is blissfully unaware. Probably you don't know what I was just talking about with the last few words there, because the world just doesn't know. And I want to help do my little bit to make people aware that this is going on for pretty much a month at this point.
Yeah, I did hear a little bit about it, but I'm not super familiar with it. I'm in Hong Kong, so we have stuff going on over here, right? So I'm quite familiar with that. And I also have a client who's in Israel, so I hear a lot about that too. It just seems like everywhere around me there's something going on, and that's I really hope that we can try to have more peace everywhere. It's totally fine. I understand. I don't want to say anything because over here is not the best. So
right.
It's getting better.
I understand.
Yeah, so if there's nothing else, then I think I have a couple of questions that you've seen at the end of the document, which I always try to ask because everybody has a little bit different reply. How do you feel about state management in Flutter, right? Why do you feel it's so complicated, and what kind of state management do you like to use?
Well, yeah, I have thought about that question. I think I have some sort of feeling, but obviously I'm not part of the Flutter team, so I don't know for sure, but I feel it... The whole UI story was thought out very well, and initially, like, it was very much the focus. And I feel maybe the whole state manager story wasn't considered early on, and that why it kind of seems bolted on a little bit, like with kind of getting kind of reaching up into the widget tree and things like that make it really complex. And so obviously, like, you could just use state, but that's not a maintainable solution for larger applications. I think there was also some sort of confusion because then Google went out and they suggested one way of doing things, and then actually an easier pattern came out, the provider pattern, I think, that people started using. So, for instance, the block pattern that Google recommended, with everything being a stream and so on, that did make sense in some sense, but having to implement one block per stream or whatever they recommended, it's just way too much boilerplate in my opinion. So what I did for the apps that I did create was I used some sort of a, let's say, a kind of block pattern, but I did not, and that's probably also some mistake that especially beginners make. If someone says X, they do it exactly by the letter, and they don't have the experience yet to say, well, that doesn't actually make sense here. Maybe I could make my life a lot easier if I would just do it a little different. And that's basically what I did. I did block, but somewhat different. I did not use the block library that kind of generates a bunch of code for you and things like that. I did also not necessarily adhere always to the thing of having to have state that is non-mutable that you have to send around. There's also a performance implication there, right? Because if every time, it depends on how often the state changes, but if every time you create a class and you send that around, and then or like an object, right, and then it gets collected by the garbage collector, that could affect your performance. So yeah, I feel like it's a little unfortunate that there is no clear story. There are just more and more libraries coming out. I can't remember. I think there was RiverPod and some others. And I'm actually going to, I looked into those in order to see, like, how can I make, how can I integrate this with what I'm doing? And for Red specifically, I mean, the state management is actually fairly simple, right? Because all the state is in Rust. And all you basically have to do is send messages somehow. And then basically when you render the widget tree, you just pull the state directly from Rust. And I want to kind of, as I said, I want to kind of show how that could integrate with the block pattern as well. But in this case, it's kind of, I would say that Red is probably more similar to Redux, even though in some ways I don't like Redux that much. But you could think of the dispatch of sending the message, and then but the state gets mutated, so there's no such thing as getting state in and then getting a new state out and stuff. So it's a little different, but you could think of it a little bit of Redux where you have one store. Actually, in the new branch, I renamed it to store, the main state, and then you get all the state from there, right?
Okay. I think, do you have any tips or warnings for beginners?
Yeah, actually, I have some answers that I thought about. And actually, tips and warnings are kind of like going hand in hand, right? So what I would if you're just starting out with Flutter, and especially if you maybe have not programmed that much, before, just take like an existing app. I mean, Flutter, when you create a project, it comes with the counter app. And I think there are other templates as well. And just like change things in there. And you can just play around with it so quickly because you can just refresh, like hot reload, and you can see how it behaves differently. Also, what I would say is, since we just talked about state management, like don't worry too much about state management at first. Just to play with it, just use set state, even though obviously it is not a viable solution for larger apps. But in order to just like play around with it, use set state, and you can always rip it out later. If your app grows or whatever. And then the other thing that I haven't seen people do is when you're basically running into a problem, and it's actually not a Flutter problem, like maybe you're not understanding how Dart works correctly. You don't have to like test it out in Flutter. You can just, create a folder and just put a Dart file in it. Like you just call it .dart and you just run it. You just say Dart and then foo.dart, whichever your files, and you can iterate much faster with it, and you can debug it, and you can try things out that way that are not related to Flutter. And then some warnings here. Don't try to do everything the absolute correct way, like everyone says in the beginning, because you're making actually just like you just want to have fun, right? Most people probably that start with Flutter are doing this as a kind of a hobby project, so you just want to hack something together, just like. Don't get bogged down, like, choosing like a proven architecture. Like now you have to learn Riverpod or whichever is the architecture of the day. And now everything gets way more complex and you probably lose motivation quickly. So you can worry about all those things after you kind of got your feet wet with Flutter in general. That would be my advice.
Yeah, actually, I do have one last question. So somebody asked a question about, is Rust performance-wise better than when you combine it with Dart? So to me it's probably about the same, but this reminded me of another question, or another thing I heard, is that the Flutter team actually stopped doing a lot of kind of switching between Dart and Dart and C. They try to isolate as much as possible because serializing and deserializing between the two really becomes quite a bottleneck. So did you? I guess you probably find something similar, right?
Well, one thing to say is FFI, like the foreign function interface, is much faster than even the channels, right? Because you don't actually deserialize things, or like at least not the same way. Like basically, you have direct access to memory, right? And so basically, when you get a struct, and then you instantiate a class from it, yes. That's performance overhead, right? Because now you have to fetch all these things from memory, and you put it in a different format, and that's what we call serialization. But that's not necessarily how you have to do FFI. Like I mentioned in RID, actually I'm not doing that. I'm actually just sending you an opaque struct, which is just basically a pointer. And every time you ask me for a property on that struct, I then just fetch that one property. So for instance, let's say you have to-dos and they have title and descriptions, right? And now you display a list of them. Well, you only need the title. Why would I even send the descriptions, right? You don't need them. So basically that's why I decided to do it that way. So the performance there is pretty good. That said, obviously every time you cross a boundary and you have to convert some Rust string to a Dart string or whatever, that has performance over it. And it was actually when I did performance tests early on, I was actually pretty amazed how fast Dart is. Like iterating like millions of items was like milliseconds. And then with crossing the FFI boundary, it was still milliseconds, but maybe it was actually 5 times slower. But I mean, putting that in perspective with the rendering, right? That's nothing. Like I mean, maybe from like let's say 20 milliseconds to 100, but that's nothing compared to iterating a million items, right? That's what we're talking about here. But I mean, your list might be like 100 items, and to build the widget tree and to render it all out, that's like way more time spent than those 100 milliseconds. Well, if you have 100 items, it would be much less. So I wouldn't, I don't think that would be a bottleneck in Flutter apps. I think actually probably the rendering takes more time, comparatively.
Okay. I don't think I have any more questions. I think we kind of went through everything I think is important. Is there anything else you wanted to say before we kind of sign off?
Just like if you like it, watch the screencast that I put up there. See if that is interesting to you. Obviously, as I mentioned, if you feel like this is interesting enough that you want to help me out, please sponsor me with a monthly donation on GitHub, so I can, put more and more time into it, and just enjoy and just build some fun apps.
Okay, with that, I really thank you for your time. I really want you to come back. I especially want to hear what's the progress, and hopefully you can get you to your 60 sponsors, because I think I can see potential, right? It's still rough, as we talked about before we started the show, but I think it definitely has potential, and you're very passionate about it, so I can see this really moving forward.
Yeah, I mean, we didn't get to talk actually about the parts that were difficult too much, but I'm definitely going to work on ironing those out to make it less rough, to make it much easier to use. So yeah, and at that point it would make sense to talk about what I find out. So I'm happy to come back.
Okay. You're welcome anytime, right? So you have the scheduling link. So if you're ready to come back on and talk about things, you can definitely schedule a session with me. So I'm looking forward to that. Okay, and with that, thank you again for coming on, and hopefully you come back again soon.
Okay, thank you.